We have another Red Hat Summit. We have a great 4 days scheduled for you, and you're going to see some great things. It's been a tradition for the last several years that JBoss and the JBoss business unit, the JBoss product set, is sort of opening up the show. And think of it this way. We're sort of the warm-up band for the main event. The main event is Jim Whitehurst at 5:30 giving the keynote. And what's the job of a good warm-up band? It's to get the audience really excited. And we've had a history of doing that in the last several years, and the way we get you excited is to show you some of the most cutting-edge technology out there in the marketplace, the most cutting-edge middleware technology. And we're going to do it again today. So you're going to see from our team here, from the JBoss group in Red Hat, showing you some of the best technology available for building applications. Throughout the next 4 days, you're going to hear a lot about open hybrid cloud, and about how Red Hat is really the only company in the marketplace today that can give you all the components to build and manage open hybrid clouds. JBoss Middleware is a very important aspect of helping you with open hybrid clouds. We're giving you the middleware to help you build the next generation of applications in this environment. So everyone in this room will move to the cloud. And most of you, if not everyone, is already doing something in the cloud. And it's not so much because the cloud is sexy technology. It helps you scale out. It's more efficient. It allows you to build applications and roll them out faster than you've ever done before. All of that is true, of course. But it's because of the business changes that are taking place in the marketplace that's going to force you to remain competitive to move to the cloud. And there's 3 major business trends taking place today. First, everything today, business is much more immediate. You need to respond quicker to your customers and your partners and your stakeholders. You need to develop applications and develop the services that support those constituents much faster than ever before, and they need to be available all the time. Business is much more pervasive. People are connected today 24/7 on everything imaginable. It's no longer just a desktop machine. It's mobile devices. It's sensors. And so being able to respond to this load of input coming from all of these constituents is going to be very important. And again, cloud is the only place that you can be to be able to support that business change. And maybe the most important business change is that you need to be aware. Cloud is generating huge amounts of data about what your customers want, data about market trends, and being able to use that data and respond dynamically to changes in the marketplace is going to be important. And again, cloud is taking the lead there. Everyone assumes, I think, when you have this discussion about cloud, that there's going to be one big cloud provider in the sky, and we're all going to move to that single cloud provider. In addition to some of the problems like lock-in and proprietariness and poor economics associated with that, there are a couple other big problems with that notion. And it's about the security, it's about data availability and data access, it's about the complexity of applications that you're building, that they may not fit all up there. And it's also about dealing with your legacy applications. So at Red Hat, we actually see a quite different scenario taking place. It's a hybrid scenario. Certainly you're using a public cloud, but it's going to be multiple cloud providers, not a single cloud provider. You'll also create your own clouds, private clouds. And you're going to also still have physical systems that you need to incorporate into this whole area. You'll use public cloud to build your newer applications, new services, and provide scale out and availability. You'll use private clouds for those applications that require more control and more security. And you'll use your physical systems not only for your legacy applications that are still there today, but to be able to deal with applications that have more deterministic behavior, that have extreme speed requirements and extreme security requirements. Now the trick is, how are you going to manage this all? How are you going to tie it all together? And so Red Hat has a notion of the open hybrid cloud. We believe this is the future. And we're the only company in the marketplace today that can provide the infrastructure software required, platform as a service software, and middleware to build and manage open hybrid clouds. With open hybrid cloud, you'll be able to achieve application portability. You'll be able to develop your applications in one environment and move them effortlessly to another environment. You'll have cloud interoperability. You'll be able to have a single management infrastructure and a single security infrastructure to manage these disparate environments. And you'll also have open innovation. The building blocks for an open hybrid cloud are open source and open standards. And we're the leader in open source, and we drive open standards. So because of the vastness of our communities and the leverage that we get because of the open source model, you'll be able to innovate faster. Let's turn our attention to applications. So now you have an open hybrid cloud. What will applications look like in the future? Your applications that you built 5 years ago and the applications that you build 5 years from now are going to be very different from the ones that you had 5 years ago. And there are three, we call them the big three. There are three big trends that are driving this change in applications and the middleware that would support them. So certainly cloud. You build an application in cloud, it will behave differently, it will have different characteristics. Mobile, everyone is connected, 24/7, not only mobile phones, of course, but every mobile device and sensors as part of that environment, the Internet of Things. As well as the third is big data. So of course, you're collecting lots of data using big data solutions like Hadoop, but also a number of NoSQL solutions, and being able to respond to these new types of applications and take advantage of the big three, your middleware is going to look much different. Let's take a look at an example of such an application, an e-commerce application. 10 years ago, what did it look like? Well, you'd have an e-commerce site, a centralized server, teeing up catalog information, being able to take orders. You'd interact with a desktop computer, and it would be this one-on-one interaction. Pretty simple. Today, that same user is not at a desktop computer. They're at the store. They have an iPhone. And so now, using geolocation, you know that this user is in the store, in the physical location. The company is now going back and pouring through big data to see what the buying patterns and what the interests are of this customer. They're now using a rule system to determine, okay, well, what do we do with this customer now? Let's give them a discount on a given product that we have in that store because you've checked the inventory system. So now you, through the mobile device, you give them a coupon for a discount. At the same time, you've tied back to the point of sale system at the local store to notify the store that there's this customer in the store with a discount for a particular item. The middleware that you use to build this type of application is much different than the middleware you used 10 years ago. So it's not your father's middleware. It's going to be much more dynamic, much more lightweight, much more flexible. It's not going to use monolithic application servers. It won't use complex integration technology. And another interesting characteristic is it will involve the business users to change the behavior of applications like never before. So this is what Red Hat is all about. This is what we're doing in the JBoss product line. And this is what we're doing in the communities that we use to do product development. JBoss is middleware for the next generation of applications. It's extremely lightweight, as you'll see. It is built to be run in clouds, but it's also built to be run on a myriad of devices. It's empowering for the developer as well as the business user. It allows a developer to use the languages and frameworks of choice, and it allows the business user, without having to write code, to get involved in the behavior of the applications. And finally, it's connectable. It allows you to connect to disparate processes and data, regardless of the location, in a hybrid cloud environment. So we are really focused on driving middleware forward to be able to address the needs of the open hybrid cloud and this new world of new types of applications that you'll be building today and the next 5 to 10 years. It's middleware that's more dynamic, more flexible, and we think of it in a word as enlightened innovation. We're going to make you more successful in the applications that you build to come. So in the remainder of this hour, we're going to show you some great technology and I'm going to introduce some of the members of the team. I'm very proud to introduce a very good friend and colleague, Dr. Mark Little, who's our Vice President of Engineering for the JBoss product line, and he's going to come up and tell you a little bit about our technology.
Thank you, Craig. So, as we've heard, cloud, whether it's public, private, hybrid, or as we also like to call it, personal, ubiquitous computing, it's here today, and it's affecting a lot of what we're doing. I mean, if you've tracked what we've said over the last few years, you won't be surprised to hear that we believe that these environments, cloud and mobile, present scalability, reliability, and fault tolerance issues that only a decade or so ago were research projects. These problems are here today, and therefore we need solutions today. And we believe that middleware, and specifically JBoss Enterprise Middleware, can help to provide solutions to these problems, or at least to many of these problems. And in order to do that, we believe that the middleware needs to have these 5 characteristics: lightweight, embeddable, obviously mobile, polyglot, and integrated. And over the next few slides, I'm going to go into a bit of detail on each of these. So, lightweight. If you've looked at what we've done with our application server project and EAP6, the product, over the last few years, you'll know that we've re-architected that significantly from what we had only 5 years or so ago. And it is incredibly lightweight now. And by lightweight, I mean you can boot the entire application server in less time than it takes me to tell you that you can boot it. I was telling somebody yesterday that you can boot it in 2 seconds, and that's the full E6 profile. And then somebody else, one of the guys who works for me, came along and said that you can actually boot it now in less than a second. So it's very, very fast, and that's incredibly important for developers. It reduces the dev, test, dev cycle. So even if, as we do, we support dynamic redeployment of apps, even if you have to take the app server down, though, to make some changes to your application and then redeploy, you can redeploy and be up and running again very, very quickly. This is important for cloud, because certainly for public cloud, one of the bottlenecks is the time it takes to push your binaries up to the cloud and redeploy. And redeploying, as I said, is very, very quick now. But another aspect of lightweightness is footprint. And part of what comes out of the re-architecture that we did around the application server is it now has a very, very small footprint. And if you were at the Keynote last year or the Keynote the year before, you'll have seen us running the full application server on plug computers and on mobile devices. And that's not a modified version. As I said, it's the version you could go and download today and try it yourself. This is, again, very important for cloud, and it's very important for ubiquitous computing, which, as Craig's mentioned, we believe that cloud, open hybrid cloud, is much more than just servers. It's a lot of these devices that are out there today in your hands, your pad, your mobile phone. So we believe that the application server, whether that's the product EAP6 or the community version that you want to kick the tires on, is a very, very good substrate for platform as a service and for open hybrid cloud. And it's the lightweightness is actually one of the things that we won this best application server award from. That was presented to us zero turnaround yesterday if you were at JudCon. Embeddable. Well, as I just said, because it has a very small footprint, it means that it can run on a number of different devices. We're no longer constrained to run on mainframes or high-powered servers or racks. We can literally run our application server on a mobile device. You can go to jboss.org today, and you can find a link which will show you how you can deploy AS7 on an Android phone. And we've spent a lot of time and effort over the last 12 months making sure that this also extends to many of our other products and projects. So whether it's transactions, whether it's security, whether it's SOA in the form of SwitchYard or Camel or Fuse Fabric, we've made sure that these things will run on what are often called constrained devices in the form of Raspberry Pis or mobile phones. And we don't do this just for the PR, although PR is quite nice. We also do it because, as I said, we believe it's important for cloud as a whole. These devices should be part of the cloud, but also if we can make our application server or our SOA platform run well on a Raspberry Pi, just imagine how well it's going to run on the typical servers that you're going to be finding on the likes of OpenShift. Now, mobile. I think that the two, Craig put up the big three. I think of the two of these big waves that we're seeing, mobile and cloud, are definitely defining waves of the next decade, if not the previous 5 years. And we think that they're actually inextricably linked together, their futures. Whether it's because your mobile application is using cloud for back-end as a service, or because the mobile device is itself part of the cloud, being able to host services and cloud burst on and off, mobile is critical to the evolution of cloud. And we've spent a lot of time over the last 3 years, and demonstrated that in previous keynotes, in the mobile arena with projects like AeroGear, working with HTML5 and iOS and Android and WebSockets and JavaScript. But we've also importantly tied in mobile to our products, to all of our products. Just as they now have to have a path to cloud, they also now have to have a path to mobile. So we believe that we're appealing with our projects and our products to people who are working in mobile, whether it's the front end that you're working on or the back end. There are obviously some dominant development languages out there for mobile and cloud. Java springs to mind, Objective-C as well. But we live in an era where there are a lot of other languages going around. And we find in cloud and in mobile, developers are using different languages to implement different services based on the use cases. And applications now are becoming incredibly heterogeneous. You're having applications running on the same VM or possibly different VMs that are written in completely different languages. And the language itself may not be immediately apparent to the invoker of a service that is being provided by a particular language implementation. But we worked a lot to make sure that whatever the language that you're working in, whether it's Ruby, whether it's JavaScript, whether it's our own language like Salon, that if you need mobile capabilities, whether it's, enterprise capabilities in the form of messaging, transactions, security, the sort of things we take for granted in the EE6 landscape, that we can provide them to you in a way that makes sense. So we have projects like TalkBox, for instance, which is essentially it's a Ruby application server that layers and leverages the EAP6 app server that you can get from us. And it does this in a way that makes sense for Ruby developers. So if you're a Java developer and you look at what's going on in TalkBox, you might not recognize the interfaces, but if you're a Ruby developer, you'll be head over heels in love with it. So I did just want to stop a second to mention another specific project that we think is going to be big in the next few years for mobile and for cloud, and it's VERT.X. So I mention this because if you've been involved with mobile, for instance, over the last couple of years, you will have seen an increase in interest in what are often called async frameworks or async stacks. And probably this has been popularized by Node.js. So we're seeing developers writing apps in mobile and cloud in Node.js. And Node.js is an async stack, and it eschews threads and blocking APIs, and it automatically scales your application across the number of cores that you may be running on. And it's becoming very, very popular. The problem with Node.js, though, is it's very, very JavaScript specific. So one of our engineers, Tim Fox, who was the lead of HornetQ, our JMS implementation, developed this project called VERT.X, which we are moving to Eclipse. And VERT.X takes a leaf out of Node.js's book. It's async by nature. You're actively encouraged to not use threads, not use blocking APIs. But importantly, it is polyglot. So the number of languages that you can use for writing your VERT.X applications today seems to grow every other week. You can write in JavaScript, you can write in Java, you can write in Clojure and Ruby. I think you may be able to write in Python, but there's a lot of new languages coming, and it has a very, very active community. And as I said, we think that as a back end for mobile, it's got a lot of promise, and it's also extremely lightweight, so we think that it can be used in a number of areas on the cloud in embedded devices. So we've got cloud, public, private, hybrid. We've got polyglot. We've got cloud bursting, where you're moving your services in and out of public clouds from private to public and back again. If you had to take down your application and change a configuration file or re-implement a service just because you needed it to move from private to public and then vice versa, then it really isn't a scalable option. You want your services to be used opaquely no matter where they are. So if they migrate around because of changes in the characteristic of the network, you still want your clients to be able to find them, and they don't have to do ideally don't have to do another lookup. Essentially, this is an integration problem. And whether you like the term or not, it's something that SOA has been successfully tackling over the last few years. And with an acquisition we did last year, FuseSource, we got the brains behind the likes of Camel, Fuse Fabric, ActiveMQ, and we have our own SOA efforts around SwitchYard, which we think if we combine these into what I've already said, the nice things about EAP, will give us a really nice integration platform in order for us to build on top of and auto scale. So this is, if you've been using our SOA platform or you're into integration over the last couple of years, this is probably something that you'll take for granted. But SOA, as of a couple of years ago, your services are running on a range of different devices, a range of different environments, and no matter where they are, you interact with them through the SOA infrastructure, and it locates and it sends the messages to them. It can do things like transformations and content-based routing. Now, this is where we're going, and in some cases have gone. Now your services are in the cloud. Those clouds could be, as I said, public, private, hybrid. And again, the SOA infrastructure is the glue that ties them all together. It's the thing that does the coordination. It's the thing that maybe does some transformations on the fly. And if these services are running on a Raspberry Pi or a rack computer, it doesn't really make a difference to the user at the end, and the infrastructure just finds those services and passes the messages along. Some people are calling this iPaaS, Integration Platform as a Service. And if you were at Camel One or JudCon yesterday, you would have seen James Strachan give a live keynote for this. And using Camel, using ActiveMQ, using a web-based development environment. So I've probably rushed through these a little bit more than I would have liked, and you can come up and grab me later if you want to hear a bit more. But we're on a road, we're on a journey, and we think that Red Hat has we have something to say about every single one of these requirements, and some of them are further along than others. But we believe that bringing them all together, Red Hat is the only company that can offer a solution for what developers need today to solve their problems today, and not what they'll, not get solutions for those problems in 5 years' time. And the best thing is, or we believe the best thing is, it's all open source. You can contribute to this. You can give us feedback. You can become early adopters for it, and kicking the tires. You can help shape the future. So with that, I'd like to hand over to Burr Sutter and some of the engineering team who will give a live demo of a few of the projects and topics that Craig and I have mentioned. Thanks, Burr.
All right, so open source has changed the tools and techniques that we use every day as developers. So you guys have seen that impact on your daily life already, and hopefully we're going to show you some new tools and techniques and technologies that I think you guys are going to enjoy. So we're going to demonstrate some innovations that you've seen out there in open source, and we're going to show those. We're going to allow you to take advantage of the best tool for the job, the best technique for the job, and you're going to be more productive and more adaptive, or more adaptable. So the greater choice is an enabler for greater innovation. So we're going to enable greater choice, and that's going to be very critical. And we're going to start off with two mini demonstrations, two lightning talks, if you will, where we're actually going to go into Red Hat JBoss Fuse and look at the IDE and look at the technology there to how to integrate an application easily using lightweight embeddable technology. And then we're going to actually show you JBoss Developer Studio and the new capabilities we have for building a hybrid mobile application. And then we're going to drill down into an application built using those technologies, using a polyglot backend. And we're going to need all of you guys in this room today, assuming the Wi-Fi works with us, and already I think we're starting to brown it out with all of you guys here in the room. Go ahead and just stop updating the Facebook updates real quick, right? So just give us a little more bandwidth on the Wi-Fi. And we're going to have you guys interact with our application with us here on stage. So we're going to have some fun, all right? So let me first introduce James Strachan. He comes to us from the Fuse source, and he's one of the most prolific open source middleware contributors of all time. And so we're very lucky to have him today to show us JBoss Fuse.
Thanks, Burr. Thank you. Thank you. Hello, everyone. Thank you. JBoss Fuse is the integration product for Red Hat, right? Fuse is made up of a number of different open source Apache projects. Most of them were created by the Fuse team and were the major contributors. The project I'd like to focus on today is a project called Apache Camel. You maybe saw some of the camel signs and wondered what those were when you came in here. Now, this is what most integration solutions tend to look like today, right? They start off kind of simple. The early days, everything's nice and easy and cool. You wire something together with duct tape and string and a script and a thing, and then you move team and somebody comes along and adds another thing. And then before you know it, you look back and you've got this big ball of mud. It's hard to understand, it's hard to change, right? Now, integration needs to be agile. It needs to be able to keep pace with the changes in your environment and your ecosystem, okay? Now, I created Apache Camel 6 years ago next month, right? And the aim of Apache Camel is to make integration easy to create, easy to understand, and easy to change, okay? Now, Apache Camel is really just a simple, modular, open source Java library. You can embed it in any Java virtual machine, use it in any application server, use any dependency injection framework, use it anywhere you like, right? You can embed your integration solutions directly where you need them, okay? Put them in an ESB, put them in your application, put it wherever you like, okay? So it's a simple Java library. It's based on the enterprise integration patterns, which is pretty much the Bible in integration. You've maybe heard people say phrases like content-based routing or routing, depending on where you live, or message filter and that kind of thing. Okay, so this is kind of the Bible of integration. And Apache Camel implements all of these different patterns. So if you've heard these patterns, it will all seem very familiar. It will help you understand it. Okay? Now, Camel has hundreds and hundreds of components. It's got a massive community of people creating, enhancing, and enriching Camel all the time. So you can talk to pretty much any technology, protocol, API, or data format. You can pretty much connect anything to anything, okay? Now, the way you create Camel routes and Camel integration flows from a developer's perspective, you use something called a domain-specific language or a fluent interface to describe in a simple declarative way your integration flows. You can probably read this slide and kind of figure out what it really means without really knowing any of the APIs or really understanding how you use, in this case, JMS and XPath and that MQ series thing that some people still use, okay? You can use Java code to describe your integration flows. You can also use XML if you're a pointy brackets kind of person, okay? Now, some people don't like writing integration flows in code. They like pictures, right? So we have some open source tooling for Eclipse and for the web apps. So you can create, visualize, and work with Camel routes completely visually through pictures. You can use your cell phone, you can use your iPad, you can also use Eclipse, right? Now I'm going to demonstrate right now Eclipse. I've only got a few minutes. I'm going to go really, really quick. If you want to know any more about this, I've got a talk tomorrow at 3:40, where I've got a whole hour to ramble on about how all this stuff works. So I'm going to whiz through it really, really quickly. I can't really demo the drag and droppy stuff, but I can show you like a few stuff. So I'm going to create a project. So this is Eclipse, right? This is Eclipse with the Fuse tooling. It's all open source. I'm going to create a new project. I'm just going to click Finish. I can't show you all the different options right now. I don't have time. I've created a project on my hard drive. There's a whole bunch of stuff in there. I'm going to go straight inside the camel context thing and double click. And we get a visual palette. So this is a drag and droppy thing that I'll show you tomorrow. So you can drag and drop things around and visually design your camel routes. You've got a big palette over here with all the various patterns and endpoints and yada, yada, yada. You'll notice over here we've got two integration flows. So the first one connects it pulls a directory for files, sends them to an ActiveMQ message queue. Okay? The second route uses a content-based router. So it consumes from a message queue, does a content-based router, then uses XPath to route XML payloads to different directory systems. Okay? So pretty simple stuff. Don't worry about the editor right now and the drag and droppy thing. Come tomorrow if you want to see more detail. So what we're going to do is just run it. So right-click, run. So that was pretty quick. I created the project, I've run it. If I pop to my console, we get some stuff running. Okay? Now a text log is kind of boring, so we have another perspective which is way cooler. So we've got this Fuse integration perspective. Now what this does is it lets you connect over JMX to remote processes and look inside them and visualize the integration flows that are running right now. So have a quick peek in here. We see, oh, there's a camel, that's cool. If we double click on it, we see, oh, there's a message broker. So this is an ActiveMQ message broker, right? This is remote invocation of a JMX. We're looking in the JVM. We're seeing what it's running. We've detected ActiveMQ, so we've got a bunch of queues. We can create queues here, drag and drop messages and that kind of stuff. I'll show you that tomorrow. Plus there's an ActiveMQ, there's a camel context. So here's a camel context, and there's all the integration flows that are running right now, okay? If I click on the first route, this is the route that goes from the directory, oh, a bit of drag and droppy, yeah, why not? We go from a directory, 3 messages go from the directory to the message queue. Then if we look at the other route, we go from the message queue, 3 messages have gone to the content-based router, 1 goes down here with XPath, and the other 2 go over here. So we can just connect to the running system, see with a picture what's going on, we can understand it, and then we can visually change it. So it's easy to run, easy to create, easy to understand, and easy to manage. Now, one thing people tend to hit, Camel's kind of too easy to start, right? It's really easy to get going. You play around, you make some pictures, you run some stuff, it's all kind of cool, and then somebody changes a namespace in XML or an XPath, and everything just kind of breaks. So when things break, because they probably will, especially if using XML and namespaces, they will break, here's what you do. You right-click on the route, and you start tracing. Okay, once you start tracing, what I'm going to do is I'm going to find a bunch of XML files on my hard drive, and I'm going to drag and drop those. Okay, so there's a bit of drag and droppy in this demo after all. Okay, so I'm going to find the camel endpoint there. So there's the queue I'm going to drag to. So I'm going to click the message. It's just an XML file. I'm clicking. I'm dragging. I've dropped. Way I dropped. I think I hit it as well. Okay, cool. So I've dragged and dropped. Now, if I browse this message queue, there's no messages there. Why? Because I'm consuming from them. Well, I'm not. Camel's consuming the messages and processing them in the content-based router. If I now click on the message route, and I'll get 3 messages. Let me just fix my column headers. Bear with me 1 second. Oh, that's cooler. So I now have 3 messages here. So you might think, well, I dragged 1 message. Why is there 3 there? Well, watch the little yellow box. So what it does is it keeps a copy of every message that goes through the integration flow. So there's the first message. Let's watch where it goes. Then it goes to the content-based router. Then it goes over here. If I drag and drop another one, I'm going to click, and I'm going to drag, and I'm going to drop it on the queue. So I've dragged and dropped a message from a file system onto a message queue. Camel's then consumed it, and the second message has taken a different way around. I've now got 6, because I've got 2 messages that take 3 hops. And this one goes that way, the second one goes this way. And as we're scrolling through, you see the payload changes here, and all the message headers change there. So we can trace messages through integration flows. We can see where that dodgy XPath messed everything up, and we can understand exactly what went wrong. Okay, so it's easy to create, easy to understand, easy to change, and easy to run. Okay, that's all I've got time for the demo today. Remember, tomorrow, 3:40, if you want to see way more cool stuff and the web stuff, which is even cooler than this. Thank you. Over to you, Bert. Thank you. Ooh, I forgot the U's and the R's.
So Apache Camel and ActiveMQ, part of the JBoss Fuse technology, is certainly a great example of lightweight embeddable technology. And it can run anywhere there's a JVM, up in the cloud, even without an application server.
Exactly.
So that's an important point. It's certainly an example of next generation of middleware. So hopefully you guys enjoyed that presentation. Now we're going to show you what it means to build a mobile application. So if you want to build applications targeting the phone as a specific target device, now we're going to show you JBoss Developer Studio 7, specifically in beta right now. And we have Gorkum Erjan over here, who's been part of our Developer Studio team, specifically working on Apache Cordova and Eclipse to bring you guys a new set of development tools. So Gorkum, take it away.
Thanks, Burr. What I'm going to show today is I'm going to show how you can actually build an application that you can deploy to a real device. So I'm going to start with a hybrid mobile application project, which is essentially a project for developing Cordova, or as some of you may know as PhoneGap applications. So once I create this project, the great thing about this project type is it actually knows how to build a native application out of your HTML and JavaScript. So if I say run on iOS emulator, what you see on the console is it's actually generating an Xcode project, compiling it, and starting the iOS emulator. And this is basically our basic welcome HTML page. Well, the welcome HTML page, although it looks pretty good, it's not very useful. So what I'm going to do is I'm going to turn this into some sort of a form application using jQuery Mobile. And for jQuery Mobile, we now have a new palette that you can use. So I'm going to start with a page. And one thing that you will notice on this palette is as I go through these fields and make changes to it, you can see a little preview of it. So for example, if I add a back button here, the back button appears right there, and you can see it. And if I remove it, it's removed. So let me start by putting my page and start and go on and let's remove this, and put some input boxes. Let's put an email field. The previews are pretty good for looking at the changes on an individual component, but at some point you actually want to see how all things are coming together. So for that, we have Browser Sim. The good thing about Browser Sim is it actually has skins that you can try out for different form factors. It also supports rotating your device. So I'm going to choose a Galaxy S here. And what I'm going to do here is I'm going to enable live reload on Browser Sim. So let's continue on and put more input fields. Let's put a date. And when I push save, as I save it, the Browser Sim just updates with the new fields. Let's continue on and put another one. A phone number. So and when I hit save, it's updated on the Browser Sim. So the Browser Sim is good for testing some of the things, but as you see, when I clicked on the mail, I didn't see the keypad. So I want to see the keypad and see how it interacts with my how my application interacts with the native input method. So I'm going to just run this again on the iOS emulator. As you can see, this is going really fast. It just generates the Xcode project, runs it on the emulator. So as I click through these fields, you can see that I'm actually getting the native input keypad. For example, for a date field, I actually have the date keypad, and for a phone number, I actually have the phone keypad. So this is one way where the Cordova is actually helping you with working with the native phone features. And while you want to work with the phone features, while you are developing it, it's very hard to work with them. So what we can provide is a simulator so that you don't need to go back to an emulator or a real device every time. So I have a project here that is a Pong game implemented using HTML and JavaScript. And what it does is it actually controls the paddle with the accelerometer events. So if I tilt this little phone shape here, it actually generates events for me. And I can actually move the paddle to the direction that I want. Well, I'm not good at the game, though. So with the Cordova sim, you can emulate geolocation, accelerometer, and many, many features, but not everything. So for example, push notification is something that you actually need a real device to run. So for that, you can, well, here's my little push example project, which you can actually say, I'm going to run it on an Android device. And what it will do is, it will basically do the same thing that it does for iOS emulator. It will just generate a project and run it. So I have it right now running on my iOS Android device here. So what I'm going to do is, I'm going to send a push notification to this device using the AeroGear push notification server, which is running on OpenShift, and see the device receive the notification. As you can see, let's put it on the background and get the little notification icon on the corner.
So that's very cool.
Appear at some point.
In the notification area.
Yeah.
So what do you see here with push notifications? In this case, push notifications using Google Cloud Messaging. So it's a unified push notification system, and you can see it right here live. And we'll show you more of this in a second. Right, so that's very cool overall. And thank you very much for that demonstration, Gorkum.
Thank you.
So what you guys got a chance to see, of course, is development of a hybrid mobile application where we took advantage of native features, whether it be the accelerometer or maybe GPS or contacts on the phone or something of that nature. And I don't know if you've ever tried to build an HTML5 Apache Cordova-based application in Eclipse before, but it would take you many, many hours in some cases to get your project started and configured. In his case, he was able to point and click, and you had run through the wizard, and you immediately have a project that's runnable instantaneously. So that is a nice innovation we see coming out of the open source world overall. So now let's go ahead and talk about what our next bit of the application is going to be. So we have actually built an application leveraging all the technologies and techniques you've heard about so far. And we really wanted to focus on an application that was polyglot in nature, leveraging the mobile paradigm, certainly. And we are going to basically show you a system that leverages the computer in your pocket and all the resources of an open hybrid cloud. So we're going to show you what that looks like right now. So to introduce that, we have the concept of Ticketmonster. Hopefully you guys have heard of Ticketmonster before. It's our example application and our tutorial that's out there at jboss.org today. It's been out there for about a year now. And it is our tutorial for how to do Java EE6 application development with an HTML5 front end using Apache Cordova for hybrid mobile application type technology on the front end. And you will basically use Ticketmonster to purchase event tickets, right? So you can get your concert tickets, your theater tickets. You know you got to get to that AC/DC concert. Take Craig with you and make sure he's there too, all right? And you guys will get a chance to then go to our auction-based application. So Ticketmonster has been a very successful business, and now they have acquired an auction-based application and a business. So you can get your fan memorabilia. So you can get your tattoos and your swag and your locks of Justin Bieber's hair, or we've got some actually fun stuff for you also. So your costuming and things like that, just so you can get ready for that Lady Gaga concert. All right, so that's what our auction application is all about. So I want to turn this over now to Bob McWhirter, who's our lead polyglot and our lead architect for this demo application. So Bob, can you talk to us about the auction application?
Sure, I'd be glad to. So this application, as Burr said, is an auction. And so we expect thousands of Justin Bieber fans, just like each and every one of you guys, out there with your phone wanting to get some item. And you want to know exactly when that auction goes up for bidding, and you want to know if you get outbid. And so we look at this and we're thinking this is a lot of push notifications going to web browsers. And the first thing I think of is VERT.X. And Mark spoke about VERT.X earlier. It's this async framework that can handle a lot of connections with very few threads. And so we're doing VERT.X using JavaScript on the server side. Because, you know, our mobile guys, they like to use JavaScript on the handset. We want to use some JavaScript as what they're talking about here on the server side. VERT.X is cool because we can actually take the VERT.X's asynchronous message bus and push it all the way to the handset. So the handset actually starts playing in the same space as VERT.X. For the back end, we wanted to cobble together a nice app really quickly, so we wrote it in Ruby and Rails, and we deployed it on TorqueBox. And we had to do some computational stuff, so we wrote that in Clojure and deployed it in Mutant, which is our Clojure app server. And to connect these two things, to connect our TorqueBox with our VERT.X, we used Apache Camel. And it's talking Stomp, the messaging protocol, off one side, and then directly participating in the VERT.X bus on the other side. So that gives us a way to flow messages all the way from TorqueBox to the end client running on a handset.
So we have JavaScript on the client application. We saw that with HTML5 and the Apache Cordova stuff. We have JavaScript running in the middle tier with VERT.X. We have Ruby, and when we have Clojure, all of that running up in the cloud. So we have both OpenShift in this case and EC2.
Yes.
All right, fantastic. So I think that's a perfect example of how JBoss has been innovating in the open source community, and certainly this is an example of what you could not do with the previous generation of middleware, and certainly not with the typical monolithic app servers of yesteryear. So Jay, can you talk to us a little bit more about the client side of the application? Show us a demo of what the auction application looks like.
Sure. So what we have here is that Ticket Monster auction demo application that we built. It's built with some of the latest technologies in the industry, from HTML5, JavaScript, Apache Cordova, and AeroGear client libraries. That handles a lot of different things, from connectivity, security, that type of thing. And as you can see here, we've also integrated social login. And I'm going to go ahead and log into this using my Google Plus account. And like a lot of social logins, what it's going to do is going to redirect me to Google's page. So I let that third party authenticate me for this new application. I'm going to come in, I'm logged in, and this is the main page for the application. This is what is going to let you know how much money you have, what auctions are available, what your point status is, that type of thing. It's also going to show things like your icon and avatar. One thing that's important to note here is with the social login, it's not all just client-side. It's actually working all the way back through the system, creating a user that's associated with our back end, but never exposing user credentials outside of the third party. Bob, why don't you go ahead and start an auction? I'm going to walk through that process. So what you just saw up here is a notification that a new auction was just started. In this case, it was Bono's glasses. So I'm going to go ahead and I'm going to try to bid on Bono's glasses. And it's a pretty typical eBay kind of style page, right? You can submit a bid. You'll see I got another notification that the bid has been accepted. That's not just client side. That's a message that's actually gone all the way back to the server. The different layers have accepted that it's a valid bid and has sent a message back. And this is using not only the back-end items that Bob talked about earlier, but also AeroGear client notifier APIs.
So this application looks a lot like it's running on the native device here. Is this an application we can pull out of the App Store, maybe?
Right. So the application here, as I mentioned, is built with Apache Cordova, which lets us use web technology in native applications so we get access to native device functionality. So it can be installed in a public app store or an enterprise app store, wherever it's needed. Like a lot of enterprise use cases, though, we also have a version written in mobile web. Uses the same basic code base, and you can then access it through the mobile web, which you guys will see later, or a native application like this.
It looks like Bono's glasses has already been sold.
And it wasn't to me.
So Bob, can you talk to us more about the back end of the application? What happens through that transaction of the user logging in and the bid flowing through the system, the bid being accepted, rejected, outbid, that kind of thing?
Sure. So as Jay said, you log in through a social network, and then we get a payload of information involving your profile picture and your email address. And that flows through the VERT.X and through Fuse, and it reaches TorqueBox. And if it's the first time we've seen you, we provision an account for you immediately, and then pass a message back through this whole stack. And it gets pushed up to your browser, where you then see that you have a current balance of $500 and 0 points. And then as auctions start, we start sending notifications up once again through the same stack to your browser. As you begin to bid, those messages flow back down to TorqueBox, where we validate your bid. If you're trying to bid less than the current price, we have to reject it. If you try to bid more than you have in your pocket, we have to reject it. But if you have a good bid, we let you know that too. We tell you, okay, your bid's been accepted, your bid's been rejected, whatever. And then we also take that stream of bids and we hand it to our Clojure application server, but which is doing some processing to come up with these meaningless internet points, which will determine the winners here today. And our scoring is that for every bid you make, good or bad, just for the pleasure of pushing the button, we give you 1 point. If you happen to have an accepted bid, then we give you 5 points. If at any point in time you're currently the leader of an auction, you are the winner of the auction, or before it's completed, you get 25 extra points. If you are the absolute final winner of an auction, you get 100 points. And so these all add up, and we display them. Closure figures out what's going on, and it sends back real-time notifications to TorqueBox, which then streams it up to our back-end console here, which is with WebSockets, so we can keep up with the leaderboard here. And Jay, it kind of looks like you lost that auction to me, perhaps.
Wouldn't be the first time.
Wouldn't be the first time. So one of the things that's interesting about the back-end business logic, all of this business logic and Clojure and Ruby and all that on the back end running up in the cloud. And in this case, we also have like a $25 maximum bid. So you can't bid more than $25 over the current price. You guys need to remember that. That's a tip for you there. So just remember that. We're going to turn this over to you guys here in a second. But I want to talk more about the real-time push notifications going out from our back-end services out across the internet, out to space, and then out to your phone. In that case, well, let's talk about push notifications. Jay, can you drill down on the push notifications?
Sure. And this is one area that really gets me excited, because notifications is definitely something that's very mobile specific, and there's almost no enterprise mobile use case out there that couldn't benefit from push notifications, whether that's live in-app or native push messaging. So Bob, why don't you go ahead and kick off another auction for me?
There you go. Good luck, Jay.
All right. And so what you actually just saw, you saw non-native push messaging coming through my iPad because the app is actively open. What you saw on both my iPod here and my Android device is actually native push messaging run through the AeroGear unified push server that we're currently developing. And that is using Google Cloud Messaging or Apple Push Network. So it's managing what devices are part of that application, providing client APIs for then sending out messages as needed. Now, what's important to note here is that the auction, it doesn't send a native push message for every single notification. You don't want it to be too chatty. So it has the capability to pick and choose what notifications are native and what notifications aren't. Now, I am going to actually try to win this red Corvette if I can get into it. 7 seconds left.
We have very short auctions.
2, and I'm going to submit. And my bid was accepted.
All right.
Oh, and I won. All right.
Good job, Jay.
So that's fantastic. So we have the push notification server, and we have all this infrastructure running in a polyglot way, right? The application servers we talked about. So Bob, talk to us more about the hosting, the backside of this application one more time.
Right, so this is all hosted in the cloud, and in actuality it's hosted in 3 clouds. The first cloud is the cloud of handsets sitting out here in the audience. Because a little bit of this app, it's a smart app, it's not just a dumb web page that's being drawn. We got active JavaScript running in your mobile device, receiving messaging, doing cool stuff. So the cloud of mobile devices. The portion that runs VERT.X and JBoss Fuse is running inside of Red Hat's OpenShift. And we did that because it's a nice platform as a service, a good place to kind of put these small little apps and have them scale up as we need it and scale down when we don't. But our back-end stuff, we wanted more control of that, let's say, so we put it in EC2. And to connect the bridge, Fuse can throw messages from OpenShift over to EC2 to our machine running there, and we can throw messages back to it, therefore kind of bridging and giving us this open hybrid cloud.
I really like how what has happened here specifically is that we've extended the middleware out of the cloud and into your mobile device. So we're going to turn you guys loose on that here in a second. But I think it's really important to understand that Red Hat's commitment to open hybrid cloud means that we've been focused on platform as a service as one example, specifically with OpenShift, in this case running out OpenShift Online. But we also offer OpenShift in the form of a platform as a service available on-premise or in your private cloud known as OpenShift Enterprise. And there's an open source project behind that known as OpenShift Origin. So all that technology is available to you today. And if you saw this morning's announcements and whatnot, you can go get up there and sign up for an account right now and, of course, run your application like you see us running it here now. So one of the advantages of OpenShift is specifically the flexibility you get of running any kind of tool or framework or programming language. You name your favorite programming language or environment. You can run PHP or Python up there. You can, in our case, run Ruby up there or Clojure up there or JavaScript up there in our case. But if you guys also know, the platform as a service allows you to auto-scale your application. So here's what I want you guys to do. If we could bring up the leaderboard and also the visualizer there, the specific OpenShift monitor that we've created. So at this point, I want you guys to go to jbosskeynote.com. All right, so you guys can just simply jump on the Wi-Fi or pull out your 3G or 4G device and go to jbosskeynote.com. and get logged into our application. And then we'll see you guys start logging into the application, and then we're going to have some fun with you and run a few auctions and see which of you guys can outbid us. Keep in mind, what we're going to be doing is specifically putting a piece of software, in this case a bit of JavaScript, because it's a web-based application. You're not actually installing an application through Apache Cordova, but it's just a piece of JavaScript which extends our bus, our messaging bus, up on the cloud, out to your mobile device, and using that for real-time interaction with you. So we see you guys starting to log in now. I see Zach and Tommy, Philip. You guys are all jamming into the system. Jenny. Right? I see you guys logging into the system now. You can see the activity happening right now in real time on the monitor. So if you look out there, the activity monitor is showing people logging in real time. And that, of course, means you guys are logging in through your Google Plus or Facebook account, going out to the cloud, and now driving back down to this desktop through a WebSocket, real-time updates to the desktop. So we're going to be seeing those things. You see 31 users coming in now, and we see a bit of load happening on the system. But you can see, I see Matt Hicks here. And I see Jim Crosley here logging to the system, Jason, Peter. So a number of you guys logging in. And we'll refresh the page. Okay. And so Steve, Daniel, you guys are all logging into the system. We see you guys coming in. We have 47, 48 users, 51 users. So, and how fast is the Wi-Fi in here? Is it great or what? It's actually doing pretty well, all things considered, with everybody trying to hit the system at the same time. Now we're picking up pace here at 65 users logging into the system. And we'll get our monitor there restarted, but you can see now we're 70 users into the system, so we're still logging in users. So let's go ahead and launch an auction. Let's go ahead and get an auction going. So those of you who are already in the system, you should get a notification to say the Rolling Stone sticker is now available. You can see we have some really cool auction items for you guys overall. Let me grab some of these here. We have a Def Leppard t-shirt. I actually brought it with me, so you know the lucky winner might actually walk away with a cool Def Leppard t-shirt. Yeah, pour some sugar on me. It's my favorite 80s band, all right?
Let's start that auction.
Yeah, get that one started.
I'm holding out for the wig.
We do have an imitation Flavor Flav clock as well as one of our auction items for your winning here today. All right?
There's the wig.
And you might not have known that Slash wore a wig, but we got a copy of that as well. Okay. And then we have Size Blue Jacket also. So you guys are getting logged into the application. We have 125 users already into the system now. And you can see that they're still coming in very quickly. We can see the bids flowing in. You can see the number of bids. In that case, 47, 48, 49 bids at $76 for Def Leppard t-shirt there. You can kind of see that we have only 2 bids for Size Blue Jacket. Not a very popular option, apparently. Come on. That's got to be a killer item. So far, it looks like Def Leppard's a pretty hot item over there in the system. Looks like Peter won the Rolling Stones sticker with a high bid of $352. I actually have a Rolling Stones t-shirt for you as well, Peter, if you come up and see me later. So at this point, Jay is still the #1 member on the leaderboard. We got to knock him down, so you guys got to find a way to pump a few more bids into the system, win a couple more auction items, and then knock him off his high horse there. All right, looks like we have almost, so we still have the Lady Gaga tattoo kit now in flight. Flavor Flav clock in flight. Size Blue Jacket's now getting a few more bids, 146 bids, 140, 150. Again, the real-time updates for the transactions you guys are making from your phone right now, going out through a messaging system, out to the cloud, out to the OpenShift system, and out to EC2, an open hybrid cloud setup. And then, of course, real-time pushes back out to this desktop here on stage over the same Wi-Fi you guys are using as well right now. All right, now we see John and Jenny and Philip. They're actually making progress and getting on the scoreboard there. And you can see the orders, the actual bids coming into the system. All right, so fantastic. And there's still people signing up. We're still 178 people now into the system overall. So just in a few short moments there, you guys were able to log in using social login, using a HTML5-based mobile application, in this case, at jbosskeynote.com. See the real-time HTML5 dashboard also update in real time. So you guys had access to that. And now we can see the, well, at this point, we should start wrapping it up. Does anyone want to win the fur coat, right? Macklemore Thrift Shop fur coat. You guys know the reference. Okay, maybe not. My teenage son told me about the Macklemore fur coat, so I should mention that. Okay, so let's shut it down. So we can actually bring it down now. And if you guys notice, watch what happens on your phone.
End up on the board up here.
On your phone, you just got shut down. We sent a message out to basically say, now you're logged out, this game is over, you can't place any more bids, you're out of the system at this point. You can still, Jay and Bob, we're still in our #1 and #2 position, But actually, John, Jenny, and Philip, if you want to come up afterwards and see me afterwards, we have something to give you. So overall, we did get a little bit of load on our monitor here. We can see that actually showing some of the load. And now, since you guys are actually coming out of the system, the load is dropping. And of course, you get a chance to actually see basically the OpenShift Platform as a Service auto unscale. Those resources are no longer necessary, so it scales up to handle additional load, scales down to basically say those resources are no longer available and no longer necessary. So I thank you all very much for your time. Hopefully you guys had a good time with this demo.